All right, so the problem we are doing today is 2626 array reduce transformation. So given an integer array nums, so an array that contains integers like this one here, 1, 2, 3, 4 integers, a reducer function. So we're actually going to have a function being passed into our function, our nums, our function, and an initial value, init. We're passing 3 arguments into this function. We will return a reduced array. And so what we're actually outputting is an integer. You can see here, one of the parameters is nums, which is an array of numbers. We have a function, which is a function, and we have a init, which is a number, and we are looking to output a number. So a reduced array is created by applying the following operations. Basically, what we want to do is we want to recreate the reduce method in JavaScript, but instead of being an object-oriented style where we just run nums.reduce, so object-oriented where we're running the method on the actual array, we're going to pass the array in with the function, that we want to run on our numbers array. And so basically what we want to do is the first time we call the function, we want to call it with the init and with the first element of the array. So in this case, with our initial value and the first element of the array. The second time we call our function, we want to call it with our current value and the second element of the array. Our current value is going to be from the first call of the function. So the first call of the function, we're passing in our initial value and the first element of the array. We're returning our value. Then we're going to take our value, we're going to pass into the function again, as long as there's another element in the array, which there's 4 in this one. So this is the second one. We're passing it in with our current value, and we're getting our value. And then we're calling the function again with our value and our nums2 until every element in the array has been processed. So we're basically iterating over this array. I'm going to show you 3 different solutions: an iterative solution, a recursive solution, and then a stack-based solution. And the recursive and the stack-based solution are not solutions I would use for a problem this simple. Iterative is definitely the most efficient and the most straightforward, but they are good concepts to learn and understand on a problem this small, so that when you do encounter a bigger, more complex or more difficult problem, or one that's just recursive by nature, you have these solutions in your repertoire. So if the length of the array, if the length of the nums array is 0, we should just return a init right away. So we'll return our initial value, and we want to solve it without using the built-in array reduce method. So you can see for our first example, we have an array with 4 elements, 1, 2, 3, 4. This is our function. Our function is just taking the accumulator and the current value and adding them together, and our initial value is 0. So you can see initially the value is initialized to 0. So we set value as 0, and then we call the function on 0 and num0. Then since our value returned from that function is 1, we call it on 1 and nums1. Since the answer is 3, we run the function with 3 and our third element, and that's going to be 3 plus 3. We get 6, and since the return from that is 6, we're doing 6 plus nums3, so 6 plus 4, and we are getting 10. Then we're just returning 10. So let me go ahead and pull this up. I have my recursive function here. Let me just jot down a little bit of pseudocode. And I'll do it with the easier. I have 2 versions of this, but I'm going to go ahead and do it with the more straightforward one. So the first thing we want to do is just, if the length of the array is 0, it should return a init. So if the length of the array is 0, we just want to return automatically. We don't want to do anything else. We know that there's nothing here to be processed, and so we're just going to return the initial value. If the length of the array is 0, just return a init. Then we are going to initialize our total or val according to the problem to init. Then we are going to iterate over the nums array, and for each element in the array, we're going to execute the function with the new, or we'll just say with the total variable as the accumulator and the current element of the array as the current. And then after all that, we're just going to return the total variable. So we could just say return total. Oops. Return total. So if nums.length equals 0, return init. We're going to initialize our total to init so that we include the initial value in our total. And then we're going to iterate over our array starting from the first element while I is less than nums.length. So from 0 until we get to the end of the array, increment I, and then this is our main operation here. And then we will just do total equals function total nums I. So we're just executing the function by passing in the total. We want to acknowledge the total, use the total, and we want to add our current element to the total so far. And we're going to use whatever returns from this function to create our new total, basically. And let's test this out. We're getting 10, 130, and 0 for these test cases. Let's see. 10, 130, and 25. So we're actually getting 0 there. Let's see what we did wrong. So in this case, if nums.length equals 0, return init. Init here is 0. 1 iterative. Initial is value. Nums.length is 0. Oh. There we go. Just a problem with the test case. And boom. We're good to go. Cool. All right, now I'll go over the recursive solution. So with our recursive solution, oh, looks like I did it for all of them. Okay. So with our recursive solution, basically there we have a base case, just like any other recursive problem, and we have our recursive case. And so our base case is just if ever our array equals 0, then we just want to return init. So we could say if the length of nums is equal to 0, just return init. And we could just, that was the same in the last one. So if nums.length equals 0, return init. Simple, simple. The recursive case is a little more complicated, but I'll go ahead and break that down for you. I'm going to type it out first. I'm just going to say return reduce nums.slice 1 function, and then we're going to say function init and nums 0. So let me show you what's happening here. And what we're doing is basically the first time we call this function, we're calling it with this here. We're calling it with nums equals this. Function is always going to be the same, and then our init equals 0. Now, when we first call this function, this is what we passed in up here the first time when we ran it. But when we call it again recursively here, what we're going to call is, since we're slicing from the first element, we're actually going to be calling this. Still going to be the same function, but now instead of init being 0, init is the value of this right here. So if init was 0 on the first call and num0 was 1 with the sum function, we're just going to add our accumulator to our current, so 0 to 1. Now our new init was 1. So when we call this function here for the first time inside the function, it's going to be that. Then we're going to be inside this second function call. And so when we call this again, it's actually going to look like this. And since the second element was a 2, and to get the init, we have to call the function, it's just going to be 1 plus 2. So 3. And so when we call the function this time, it's going to be slicing off the front. It's going to be 3. And then same thing. Next time we call it, it's going to be 4. Function's always going to be the same. Our last value was 3. Our nums2 was 3, so it's going to be 6. So this is actually going to be called with 6 and that. And then last but not least, this is going to be an empty array. 6 plus 6, or 6 plus 4 is going to be 10. And so we're going to be calling this reduce with an empty array. The initial value is 10. And now we've reached our base case. And so we've reached here. So nums.length is 0. Init is 10. So we're just going to return 10. Boom. Return 10. Return 10. Return 10. Return 10. Return 10. And you return 10 from being nested 4 elements deep, basically. So pretty simple. Like I said, you wouldn't use this one for this problem because it's O of n space, because you're going to be calling this function. You're going to be calling this function for every element. So that means you're going to be calling this function 4 times, and that means that there's going to be 4 functions on the call stack using memory for each element that exists. And for really big problems, you could actually run out of room on the call stack, which is bad. So nice to know, but not practical. And then last but not least, we have our stack solution, which again is not very practical, but it's nice to know, have this for future problems, mostly for problems that already require a stack. So if like you're already using a stack, then it might make sense for something like this. Let's see if there are, if a problem requires you to yeah, I'm trying to think of another usage for it, but basically if you're already using a stack, that would be the go-to. So I'm going to go ahead and just top the pseudocode out, initialize total with init value. So we're not even doing the check here. we're just going to say let total equals init. We're going to say create the stack. So we're going to say let stack equals just our nums array. We could actually even, we don't need to do this. I was going to add this just for clarification, but we don't even really need to do this. We could just take the nums and just reverse it. So that we could pop it. So that we could pop things off it. And when you pop, because initially we're going to have the array like this. And we're going to use the pop method, and if we've popped the last one off and we go to the front, then you're going to be doing these calculations from the back to the front. But then we run into functions sometimes that aren't just adding the accumulator with the current. You run into stuff like this, so the order actually matters. So we have to process the first one, then the second one, then the third one, then the fourth one. In this case, we want to reverse the nums array so that it looks like this. So that when we pop the last one off, we're still going from the back to the front, but it's the actual order of the array because we reversed it. And then we're just going to say pop elements off the stack until there are no more elements. So while nums.length. So one reason you would create a stack here, so let's just say create our stack, and we did let stack equals nums, and then we just used our stack, and we'll do this. One reason is just if we need to maintain the quality or integrity of our initial array, like if we want to keep a copy of it just for future use or not modify it in place, then we would just use the nums and we create a separate stack, because by the end of this our array is going to be empty, and if we want to be able to reference back to our numbers array later on in the function or somewhere else in the program, we don't want to modify it. So we could just go ahead and say run the function to change total, and we would just say total equals function total. Now instead of num0, we're not iterating through nums, we're just popping an element off the stack for every element on the stack. So we'll just do stack pop, and that's going to give us the value that we want to pass into the function, and then we just return total. So let's go ahead and test this out. 10, 130, 25. Let's test this in LeetCode. Test all our solutions in LeetCode. I'll go ahead and test the recursive solution as well. You can see from memory that's horrible. For time it looks half decent, surprisingly. Let's see what the recursive solution is showing us. Recursive, like I said, should still be bad for memory, especially for bigger arrays. And we'll check our iterative solution as well. Yeah, that's really bad for this problem. So unless the problem is recursive by nature, or yeah, I can't think of another reason you'd want recursive on this particular problem, but there's definitely problems that require that concept. So yeah, and then this is the iterative solution here. So you could see, boom, 99.95, 99.8. It's just really doesn't get any better than this right here. So you really want to go with the iterative solution. It's the most efficient. It's O of 1. Time complexity, space complexity, O of 1. You're not creating any extra space, and it's O of n time complexity. So you're just executing this function once for every element on the array. So pretty straightforward. As straightforward as it gets for a problem like this. And then, yeah, that's it right there. If anyone has any questions just on any of these solutions here, feel free to leave a comment below. Otherwise, have a great night.